Welcome! This is a tutorial on how to export your Rhino model and import it into Blender. There are many different ways to do this, and an alternative workflow might be more to your preference, but this particular workflow is one which has consistently worked for us, personally, and is showcased here as an example. The main assumption for this workflow is that you do the 3D modeling and the intended material slot assigning here in Rhino, and UV editing and shading in Blender. You don't need to order your layers in a nested logic like this, as long as you have the actual objects in a layer with the m_ prefix, because it is only the utmost layer in the hierarchy that will be used in Blender for the material slots, but with this nested logic you can easily select, as an example, all window sub-objects, although they are intended to have separate materials. And if you want to change the intended material slot for any type of element, you can just rename that specific sublayer. All unique layer names will be separate material slots in Blender. So if you have multiple, they will be treated as one in Blender. For any glass panes, it is recommended to only have a single surface per window opening to make it easier to render in Blender. Let's disable this clipping pane and select every Brep object that we have here. 11 surfaces and 68 polysurfaces. Now we want to generate meshes from these Brep geometries. Type and enter the command mesh. For the meshing settings, these are the recommended one. So with density set to 0, density will be disregarded as a parameter for the meshing. With maximum angle having a value of 8, there will be a maximum of 8 degrees deviation that is allowed for the mesh with regards to the original Brep geometry for curved surfaces. For the maximum aspect ratio, we can set this to 10, since oblong mesh faces are not too problematic in this workflow unless they yield very thin triangular faces, so we still want to have it as a threshold. As for the minimum edge length, we want to make sure that the mesh does not generate any edges that are shorter than 1 mm. That will be 0.1 centimeters in Blender. Maximum edge length, maximum distance edge to surface, minimum initial grid calls can all be set to 0. Those will not be used for thresholds for the meshing. We want to have refine mesh active so as to make sure that these settings are put into effect. Jagged seams we want to keep disabled because we want all bordering Brep edges to be bordering mesh edges. Simple planes we can have as active so as to reduce the amount of vertices generated for flat surfaces. And all of these settings you can of course experiment with, but these have consistently worked for us. Press OK to confirm the meshing settings. After the meshing is complete, type cell last to select the previously generated meshes. With the meshes selected, type and enter export. Change the file type to OBJ. Choose a suitable name for the exported model. Press enter or click save to confirm. As for the OBJ export options, they can be set accordingly. For the first tab here, we only have meshes selected for export, so it is not relevant for us. As for the formatting, make sure that it is a Windows end-of-line character, and to our experience, 12 significant digits are more than enough. That means that to retain a precision of at least 1/100th of a millimeter, 0.01 millimeters, you can have vertex points situated as far away from the origin point as up to 1,000 kilometers. So we deem that generous enough. You don't want to export material definitions. The intended material slot assignment has been with the assigning of these layers, but we will be creating the actual materials in Blender. Make sure to map the Rhino Z-axis to the OBJ Y-axis, so as to properly import it into Blender afterwards. Make sure to disable wrap long lines. For the naming tab, make sure that you select do not export object names, and do export Rhino layers as OBJ groups. This is the logic that we have the intended material slots names as layers. Make sure also to sort by OBJ groups, that is layers. For the fourth tab, Mesh, make sure that vertex welding is set to welded, do not create n-gons, and make sure that you don't export texture coordinates, vertex normals or vertex colors, but do make sure that you export open meshes, as an example, our window panes. Click OK to save the OBJ file. To keep the Rhino file tidy, we usually undo with Ctrl-Z the meshing, so that we still only have the Brep geometry here in Rhino. Let's save this file, close Rhino, and open Blender. If you have a fresh install of Blender, you might be asked some fundamental settings for left-clicking, selecting, etc. The defaults work perfectly fine, just make sure that left mouse button click is selecting. I'll click outside the splash here to get into the default startup scene. And then the first thing that we're going to do is to select everything. I'm going to activate this plugin here so that you can see what keys I am typing here. So select everything with A and then press X to delete and confirm with left mouse button clicking. It is very important for the succeeding scripting that you will import the model into an empty, completely empty scene. And then if you want to import more Rhino models using this very same workflow, make sure to import them individually, each into one separate empty scene. And then you can append or link via the file menu the other imported model into your main scene. Now let's make sure to import our exported OBJ. Maneuver to where you saved your file, click it once to select it, and here for the import settings, make absolutely sure that you do not split by objects, but that you do split by group, because that was the logic. We exported from Rhino all of the objects assigned into separate layers, and where the layers should be sorted into groups. So make sure now to split it by groups. And click import. Take into account here, in Blender, as in Rhino, you can use any unit scale and unit system, metric, imperial, and unit scale here. Since we primarily use Blender as a gateway to Unreal Engine, which we will not cover in this tutorial, we still do have the unit scale set to 0.01 meter, that is 1 centimeter, because in Unreal Engine, 1 unit is 1 centimeter. But you can set this how you want. If you have the option separate units checked here, no matter which unit you are working with or unit scale, you can still see all the different meters, decimeters, centimeters, millimeters, etc. depending on the actual scale of the object. So now, with everything imported, the first thing that we can do is go to the scripting workspace here, and then there is a script included in the description of the video that you can copy, and activating the Python interactive console here, Ctrl-V to input it here, and enter once, and you are done. We see here that we have now one object with material slots instead of that long list of objects with no material slots. We can go back to the layout workspace. The script might have generated some garbage in terms of unused data blocks, so we can go to File, Clean Up, and clean up recursive unused data blocks. And then we'll confirm with left mouse button click. Very good. Now, when the objects are all merged into one object, we can go to the Item tab here, and then we can see here for the dimensions of the active objects that these dimensions are exactly 10 times larger than what they should be. So in this case, it's very easy. And the reason for that is that we worked in Rhino in millimeters, and here in Blender, we are working in centimeters. But you can use any unit here as you wish. A good thing is to enable the separate units here, because then no matter which units you are working in, you see the most relevant unit in the dimensions, etc. So even though we are working in centimeters here, we see that we have dimensions stated in meters here. If we scale this with a scale factor of 0.1, to select all 3 fields, click and drag, and then do scale 0.1. And now the dimensions are as they should be. Very good. With the object selected, we can see here that we are in the middle of it here, but with it selected, you see here in the outliner here that is yellow and selected, you can press the numpad period key, or on Swedish keyboards it's numpad comma, and then you can see the whole object. If there would be any clipping, I will showcase this by going very far out. If there would be any clipping, you can go to the third tab here, View, and then change the clip start and clip end. So in this case, if we would be dissatisfied with this, we could increase the clip start end to 1000 meters, 1 kilometer, and we see that we have a more generous range to work with here. But if you set the range too far, with a too large range, you will start to see approximation errors in the viewport. So if you encounter that, also go here to the clip start and end and perhaps constrain the range. I'll change back here the clip end to 100 meters, and then we'll find our object here, numpad period. If we go to the first tab here, item, we see that we have an imported X rotation of 90 degrees, and we also scale down the object to 10% of its original imported scale. So it makes sense to Control A to apply all transforms, which makes sure that these transforms are applied to the object and the transform data matrix is reset. Very good. Let us navigate to where we would want to have a camera. Navigating in Blender might be a little tricky if it's your first time, but you hold the middle mouse button to orbit the viewport camera. You can hold Shift and middle mouse button to truck the camera like this, and you can hold Control and middle mouse button to dolly it forward and backward if you like. Let us navigate to the center of the object here, so by dollying in here and then panning around with middle mouse button, and then trucking a little to the right and tilting the camera upwards like this. This might be a good starting point. To create an object, hold Shift and A to add, and then we add a new camera. This camera is now created in a default position here, but we can assign our current viewport perspective to the angle of the camera by having the camera as active, which is here, it is highlighted, and then hold Control, Alt and numpad 0. That makes the currently active camera have the current viewport angle as its perspective. Now you are in a camera viewport, so to say. You can press the numpad 0 to enter and exit. Now there was no real difference because we do not have any different viewport angle than the one that was set for the camera. But we can orbit around here, and then we can remove, and then we can at any time press the numpad 0 key, and we can go back to the camera that we have. For such a cramped space as this, I think we will need to decrease the focal length, perhaps to 27 millimeters. Yes, and then to rotate the camera here, now it has too much of an upwards tilting angle, we can press the period key, and then we see here that the pivot point of anything that we want to rotate or scale is now the median point of all selected objects. And that will of course be the individual origin if we only have one object selected. That's okay, we can press period again. This means that when we now rotate this object, it is selected here, and we press R to rotate. Now if we rotate like this, it will be viewport aligned rotation, which is not a good thing in this case. We want to make sure that we rotate it around the local axis, which one we will see. If we press X once, it will be along the global X-axis. And that was not what we intended. We'll do X once again, and now it is the local X-axis. Very good. So now we rotate the camera object here along the local X-axis. And then we can perhaps set this one. And now, if we, in this camera viewport, we can also zoom in so as to get a closer look of what is inside. And we can also hold the middle mouse, and we can also hold Shift and middle mouse button to look around here what can be shown outside of the camera frame. I think that we would really like to go backwards a little, to dolly backwards. So we'll press G for grab and move. And then the local Z axis should be the forward vector here. So we'll do Z and Z. Then we can go backwards here. Very good. And we can go backwards until we are perhaps here. And then I think we want to boom the camera a little. So we'll do grab and move and lock it to the global Z axis. That is upwards here. And then we can move it upwards a little. Perhaps like this. And perhaps we also want this to be symmetrical, so we can do a rotation of the global Z-axis. And then if we do a fine adjustment like this, and then if we do the grab and move the Z-axis, we can see that it is not. So rotate, Z-axis, and when grabbing and move here, we saw that the camera is not centered on our corner here. It might be good for symmetrical reasons. So we can go to the viewport display in the camera options and show limits perhaps. And then we can simply do rotate with R and along the global Z, And then we can see here if we can make it like this perhaps. We see that we have a slight Dutch angle, so here in the item pane here we can just reset the Y rotation to 0. Great. And now we can rotate along the global z-axis and have a completely straight line there. Very good. Perhaps we want to be a little higher up. Perhaps here, approximately 1.5 meters above the floor. And then we can rotate along the local x-axis and then do perhaps like that. All right, we can disable the limits showing here in the viewport. Very good. And the focal length is adjustable here as we did previously. So we can adjust from telephoto to fisheye. And I think that 27 millimeters was good in this particular scene. And if you want to change the aspect ratio, you do that in the output settings here. So now we have a resolution of full HD. And if you increase this, then of course it gets wider. And likewise, if you increase this, then it gets higher. All right, we want to slightly adjust this. So let's do negative 135 degrees. And then we can show the limits here again. And then we can truck it instead. Okay, I think that's symmetrical enough. Make sure that you don't forget to save the file with Ctrl S. And now to do a very quick render of this from this camera view, we can just first go to render options here, and we see that the current render engine is set to EEVEE, and EEVEE is a very quick and fast and efficient sort of like real-time renderer. As of now we don't see anything because we don't have any light source. We can go back to the solid view mode here, and then we can hold Shift and press A to add, and then we can add a point light. Let's see here, a light and a point light. And it was created here in the origin, but we can move it, grab and move, and then Shift and Z to lock the Z-axis, so as to move it perhaps there. And then we can grab and move and lock it in Z-axis, and then we can move it up there. We can look at this now in the rendered display mode here. And there is still not much going on here, so we might need to increase the light power for this light. So we go here, yeah, now it's a very, very minuscule amount of power here. We can do 25 watts perhaps, and we see something like this. And this is both an advantage and a disadvantage of EEVEE, that you get a really, really quickly rendered image, but you also get lots of these artifacts and approximation errors. So it's very good to like get the feel of light intensities and how your scene might look, but for a final render, it is recommended to use Cycles as a render engine. And you have two sets of settings here, one for the viewport and one for a final render. And for a final render, the settings are more time consuming, and for a viewport rendering, it is less time consuming. So with these settings, we actually achieved good enough with this noise threshold and some samples of 1024. We have already gotten the final viewport render. But for a final render, you might want to adjust these settings so that you get an adequate final result and not something like this. So to quickly compare the two, we can change back to EEVEE as render engine, and either we can press F12 on the keyboard or we can click a render and render image. And this will render an image from the current active camera. And we see that we got the result immediately, but it is not a very good result. We can save it anyway. And PNG file format, RGB color, 8 bits for color depth are more than enough. Save as image. All right. It took approximately 1/10 of a second if we click X here to close. And then we'll change from EEVEE to Cycles as a render engine. And then we'll do render and render image. And here's an important thing. I did a mistake. Never start a render while you're actively rendering in the viewport here. So either you press the pause button there, or you change to another display mode that does not use the Cycles render engine. We can have the render display mode here, but make sure to pause it. And then we can render the image. So as you see here, we get a much higher fidelity image, but it takes a lot more time. Instead of that 1/10 of a second, we are now at 20 seconds, and we have approximately 1 hour left. This image we might not want to wait for. We can at any time press escape to cancel, and then we can do image and save, and RGB 8-bit depth. Okay. And then we can close this window and we can go to that folder And we see here that it was this image versus this image. So we can compare here these two images. One thing that you can do to, instead of changing between EEVEE and Cycles all the time, you can work primarily in Cycles, but make sure that you, let's pause this, but make sure that you, for the output, that you select a percentage, a resolution percentage of perhaps 25%. And then actually going back to the render settings here, and then we can change the noise threshold for the final render setting here to 0.05. So half the noise threshold of a viewport render. And then we can press F12 to render again. And it's a very, very small image. But since it's a very small image with a very limited amount of pixels and also with a much less strict threshold for the noise, then we get an image after 6 seconds. And this image might tell you more iteratively about how the scene is developing than a very noisy larger image. So we'll save this as well. And then we can close this window. If you want to show the last render, you can go to Render and View Render, or hit F11 on the keyboard. And then that will show you the last rendered image. In this case, I think it's good to also say that if you save this image, that when you're doing these iterative tests, it might be wiser to save it as JPEG, since the saved file size will be much less. But when you are approaching a final render, you might want to save it as a 16-bit PNG, so as to retain as much color information as possible. For these tests, however, we'll stick to 8-bit PNG. We can click Cancel and close this window. Let's save this file with Ctrl+S and then move on to normal editing, UV editing, and shading before returning to the final render. Let's change to the solid display mode, and then we can exit the camera view by holding the middle mouse button and orbiting out, and then we can truck it a little here and dolly it a little here, and we can focus on this area around this crown molding. When it comes to normal directions for the surfaces, it is nothing too complex. All of the vertices have a normal direction. This is the direction which the render engine interprets as the perpendicular direction of the surface for the given vertex. For flat surfaces, such as the door here, the normal direction of the vertices should be one in each corner here. We can see that if we select the object, as it is now, we see here it is highlighted in yellow, and then press Tab to enter edit mode. We see that we have a vertex there, a vertex there, a vertex there, and a vertex there. Tab to exit edit mode and enter object mode. For flat surfaces, the normal direction of the vertices are pointing all in the same direction, which gives the appearance of a flat surface. For curved surfaces, such as this handle here, we see that as of now, the normal directions are faceted, which they should not be, because for any surface with segmented edges which should be interpreted as a curved surface, the normal directions of the vertices should be averaged or smoothened to make the render engine interpret them as curved. We can do that like this. Press Tab again, we still have the object selected here, to enter edit mode. And then we can click this button or press 2 on the keyboard to activate the selection mode edge selection. And then we can select and select sharp edges. And the cutoff value for this can be set to 30 degrees. You can experiment with this so that it is good for your particular geometry. Perhaps 18 degrees might be good, so as to make sure that this whole curve is interpreted as sharp. Let's see here, period comma to escape. Let's see if that created something bad in any other way here. Yeah, that's good. So in this case, we did 18% instead of 30, but 30 might be better in your case. With these sharp edges selected, we can hold Ctrl and press E to open the edge options here, and then we can mark these as sharp. That will explicitly mark these edges as sharp. The previous select sharp edges, that was only a temporary selection with a threshold value, but now we have marked those edges as sharp. all sharp edges will have their vertices normal directions split between any bordering surfaces, which means that even if there is only one edge between two bordering surfaces, the render engine will interpret the vertices of that single edge as two separate sets of vertices with independent normal directions. As such, it is good procedure to also mark these sharp edges as seams. A UV seam will, when the mesh is unwrapped, necessarily increase the number of vertices the render engine will interpret as separate, but if it is already marked as sharp, there is no additional performance cost for marking it as a UV seam, and in this case it will be easier to unwrap the mesh. So let's open the Edge menu again with Ctrl E, and then we'll mark this not only as sharp, but also as a seam. Great! Before unwrapping and UV editing, first let us make sure that the normal direction manipulation actually is put into effect. As of now, we have only prepared for it. We can hit Tab to exit the edit mode and return to object mode. Make sure that the object is selected by being highlighted with the yellow text, and then right mouse when you click in the viewport and click Shade Auto Smooth. And you might have noticed that these curved segments, they are now shown for some areas as smooth and for some areas as not. As you see here where it creases, there's these shading artifacts, but we will fix these soon enough. Make sure that the threshold angle for the auto smoothing is the same or higher than the one you previously used when you marked your sharp edges as sharp. Otherwise, surfaces will not be rendered smooth, instead having faceted normal directions. We can show that here. Now with 30 degrees, this is shown as smooth, but if we decrease this, you see that it is still faceted. So this can be 30 degrees. The important thing is that it's higher than what you previously used when you explicitly marked your edges as sharp. During the meshing in Rhino, tab to enter edit mode, there might be some areas with too densely populated edges for the auto smoothing to properly work, such as in this crown molding corner. So we can start with adding a modifier to alleviate this. Press tab to exit edit mode. We'll go to the modifier tab with the wrench icon, and you click add modifier, and then you can go to generate, and we're gonna do first decimate. Make sure that the decimate mode is set to planar, and you see that immediately the shading of this area was significantly better. But we can experiment a little with the angle limits. If we decrease the angle limit too much, then the problem reappears. And if we increase the angle too much, geometry gets deformed, as you see here for the handle. And also here for the crown molding. So if we set this to perhaps 8 degrees and verify here that the change is not too significant. Yeah, looks good. And here as well. Yeah, looks very good. So in this case, an angle limit of 8 was good. We changed the triangle count from, if we click this viewport display icon we can see here, from approximately 38,000 triangles to 5,850. That's good. And as a bonus, we got a better shading of problematic areas. Having decimated the mesh, we should also add a modifier, generate and triangulate, so as to make sure that any n-gons and quads which were generated during the decimation get re-triangulated with the beauty method for both quads and n-gons. And now with the mesh properly triangulated again, we can add another modifier, edit, weighted normal, and with the weighted normal modifier, we can fine-tune the normal directions. So the first thing to do here is to check keep sharp, so that our sharp edges are still treated as such. And then we can see if we zoom in here a little with Control and middle mouse button, that looks good. For the handle here, let's see if this can be improved. If we reduce the weight here, if you have a lower weight, the smaller faces will have a proportionately larger influence here, so perhaps 25. Yeah, it might look better. It's good to note that we never look at this handle from this position. We will look at it from here. So if it looks from here, then it's good. If it looks good or bad from here, that's not too interesting. Yep, 25 is good. Great. And let's double check the crown molding here. Yeah, looks good as well. Very good. You can at any time toggle the display viewport effect by clicking the button here. So now there's the pre-decimated one. It still gets triangulated and weighted normal assigned. And for the same for the weighted normal, there's a slight difference there. And for the decimate modifier here, if you toggle it, you see also the number of triangles that we had before decimation. If you don't have this scene statistics, you can right mouse button click the lowermost pane here and activate scene statistics. Very good. All right, I'll toggle it again. The modifiers in Blender enable a non-destructive workflow, but you can anytime hover the mouse over and press Ctrl A to permanently apply it to the mesh. I'll press Ctrl Z to undo that. For our workflow, it's a good thing to apply the decimate modifier, since the next step, UV editing, will greatly benefit the fewer triangular faces that you have, because the unwrapping will be less computing intensive. And as such, it's good to apply the decimate modifiers so that you make sure that it is the mesh itself that gets decimated by applying, and not only the viewing of it in the display viewport. But before applying, I'm going to Ctrl Z once again. We can make a copy of the original mesh with Shift D and then right mouse button click to confirm the duplication without translating it to a new position, and then you can simply press H to hide it. And now you see here in the scene outlier that it is hidden. It can optionally be renamed. If you select it and press F2, you can rename it, perhaps _original. Or it can be perhaps put into an entirely new collection here. Press this button and then perhaps rename this to backup. And then we can just click and drag it into the backup folder. And a nifty way here with having it in the collection is that you can just uncheck this and it will be hidden both from the outlier and the viewport. Let's make sure now that we select our model that we want to work further with and that we hover the mouse over the decimate modifier and Ctrl A to apply it. Very good. Now we can go to the UV editing workspace. So click the tab here to go to the UV editing workspace. Each workspace has individual viewport settings, so now we are very zoomed in and we can press the numpad comma key here. For these kind of objects, intended to be textured with real-world scale material textures and not individually painted, the following workflow is what we usually do, but it can be done in many different ways. Let's first press Tab to exit editing mode and enter object mode again. And then we'll do like this. Shift A to add a new object. We'll do a mesh plane. We'll click the small triangular icon here to expand that. And then we make sure that the size is 2 meters. That's a good real world reference. And then we make sure that the generate UVs option here is checked. We can move this. Let's move this up. So we'll grab and move with G and lock it to only move in the Z axis by pressing Z. And then we can move upwards, and it's a little difficult to see where it's actually on top of our imported object here, but approximately there. Very good. And left mouse button click to confirm. And now we can, with this plane selected, we can press Tab to enter edit mode. And since we are already in the UV editing workspace, we can see here, since we had the generate UVs checked, we have this 2 × 2 meter plane as a UV island that goes from the UV 0 to 1, 0 to 1 UV space here. Now we want to create a new image, so we press the new image button there. The name can be templates. The width and height should be 2K, so if you click and drag from the first to the second field here, and you can enter 2048 for both, enter to confirm that value. And then we don't need an alpha channel. The generated type should be a color grid, and then we can press OK. And having generated, we can zoom out a little so we see the image, and you see that all of these squares are distributed in the UV 0 to 1 space. We can go image and save, so to save this image, and then we can save it in a good folder, perhaps textures, and then we'll do template 01. And let's say this is as a 8-bit PNG, that's good. Now, having created this image, let's go to the shading workspace. It is this workspace tab. And with the plane selected here, we can do numpad comma while the mouse cursor is in the viewport here. And we are directed here. Very good. For this material, we do not have in the material here, we do not have a material slot here, so we'll make a new material for a new material slot. We'll do m_templates. The base color input of the shader should be, let's do Shift A, and we can do texture, image texture. And as the selected image texture, we should select the one that we previously generated, the template one here. And then we can connect the color output to the base color input of the shader. And as of now, we are in the shading workspace with the material preview shading here. We can also select solid one, and then we should make sure that the color that we see here in the solid viewport or solid display, that it is the texture one. So we see it here. Very good. And now to make this work, we should select all of these nodes and then either right mouse button click and copy, or as you saw, Control C. And then this object has only one material slot, it's m_templates. Then we should select our 3D model that we imported, which has a lot of material slots, and then we can go through these material slots either here or here, it's the same. And then we'll take the first one, and then we'll use nodes. And when you click use nodes, these are by default selected, and you can press X to delete. And you already have copied the template node, so you can Control V to paste it here. Those are already copied, so we can just change the slot here to the next one, and then enable use nodes, and then delete with X, and then Control V. Very good. And we'll do the same for the rest of the material slots here. The texture is not showing yet for our imported object, since it does not have any proper UV coordinates for its vertices. It has not been unwrapped yet. Let's go back to the UV editing workspace. Make sure that you are in edit mode for your imported objects. And then you can, in any selection mode, you can press A on the keyboard to select everything. Press U for the UV mapping menu, and then U again to unwrap. Change the method to conformal, which usually yields more reliable results for hard surfaces, such as for this model. And the margin can be set to 0.0016, be left at its default value or set to any other value, since we will not be painting this mesh, and as such UV island inbleeding is not such an important matter. As you saw, we have one failed unwrap for one of the UV islands, and we will look into this later. If it is an object that is not showing in our intended camera view, it might be unwise to take the time to fix it. If it does not show, it does not matter, and if we see it, we should fix it later. As of now, everything is unwrapped to fit within the UV 0 to 1 space, which is adequate if we would only use one texture set to shade the whole object. But we will use several different texture sets and are more interested in making that a smooth endeavor. So, with our 2x2 meter plane here as a reference, perhaps we should position ourselves a little better. First, we should change the view mode here. Yeah, it is already to solid, this display mode, but we should change it to texture. Very good. And now you see it, since we have unwrapped it, we have a proper representation of the image texture that we have currently assigned as the material texture. Then let's see if we can press numpad 7 to go to top viewport. That's good. And then if we look a little closer here, we see that this is according to X and Y. And the top surface that has been unwrapped here, it is not. So it might be wise to first click in the void, make sure that you select with number 3 so that you are in face selection mode. Select the top face here, and we see it here. And then perhaps we should make sure that with period, in this case, bounding box center is good. Then we should rotate this. Let's see how many degrees. 270 degrees. So that this reference surface is also oriented the same way as this reference plane. Very good. Now you can click in the void and press A to select every UV island here. And as of now, it's a little tricky to see because of highlights here, but we can temporarily toggle the overlay, and that will make it easier. So with the mouse cursor here in the UV editing workspace or viewport, we can hit S to scale, and then we'll scale this up until they are roughly the same size. So perhaps somewhere around here. I'm not too certain, but let's try this. If we scale here, yeah, that might be approximately the same. And then we can G for grab and move, and we can move it here and see where we can find it aligning. And if it does, I would say that we have a fairly good Yeah, it's not totally perfect. You see that there's a small difference there. We can try to remedy that. Let's see here. Where should we look at then? And it is a little too large, the texture. So this should be a little larger, the scaling of the UV island. All right, and then we can see here. If we can find this, there it is, okay. Yeah, that's really good. I see that there's a slight misalignment there, but generally that is definitely within tolerance. That's good. All right. Now if we zoom out here in the UV editor, we see that all of the UV islands are approximately scaled so that the UV 0 to 1 space corresponds with a real-world reference dimension of 2 × 2 meters. We can go back to the layout workspace and see how everything looks. And here nothing has changed, of course. We need to change the color here to texture. Everything looks uniform enough. And now would be a good time to hit numpad 0 on the keyboard here. And here, if we scroll in and then with shift and middle mouse button, we see here, does everything look uniform here for our intended camera viewport? Everything looks good. Good meeting there. Ah, here we have the culprits, the one UV island that was not possible to unwrap. And in retrospect, it's quite evident because this is a cylindrical bent object with no sharp edges, so this would have no UV seams either. But that we can fix. Let's see here. Let's make sure that this is here. Yeah, this is definitely wrong. Let's go back to UV editing. And then let's see here if we can find the same place again. So is it there? No, it's not. Is it there? No, it's not. Then I guess it's here. Yes. And now we're already in edit mode. So let's see here if we in face selection mode, we can select one of those faces. We just clicked here haphazardly and then numpad and we are moved in here and we see him more clearly. And we can do like this. If we hover the cursor above the object or the sub-object here, we can press L to select every entity, vertex, edge, face, that is directly connected to it. Let's make sure that we re-toggle the overlays here so that we see the selection. Very good. Now with this erroneously unwrapped objects selected, we can do U here for the UV mapping menu, and then instead of unwrapping, we can do a smart UV project. And default settings work fine. Okay. So now we see here that UV seams have been automatically generated. They might not be in the best position, but we will not look too closely at this object, so it is okay if they have a seam here right in the front. If you would do it manually, then you would select your edges, perhaps like this, and then Control E and mark seam, and then unwrap it in the usual way. But for this case, the UV Smart Project is very good. All right, let's click to link select all of those again so that we have the UV island selected here in the UV editor. And then now the important thing is to make sure that the scale of this, because now it has been unwrapped to fit the UV 0 to 1 space again. So then we can temporarily toggle the overlays again. And then let's see here, if we look at it from this place perhaps, then we can just do S for scaling here. And it should definitely not be larger, the UV islands, it should be smaller. And it's quite hard to see here. Let's see here. Do we get any character that shows? Yeah, we can see here that that is still wider than that one. So let's do it smaller. Or is it larger then? Yeah, larger. Okay, good. Then perhaps that size is approximately the same as that size, and that means that this UV island is scaled again. And we see on the backside we have some meshing artifacts, perhaps due to the decimate modifier. It's okay, this will not be shown in the final render. With all of the mesh faces properly unwrapped, we are ready to actually shade the sub-objects with actual material textures. There are many different sites to acquire material textures from, with different licenses, but it can be briefly as said the name of two, both of which are independently financed via Patreon, and thus they are financially able to publish their work with a public domain CC0 license. so that anyone can download and use their published contents for free. No strings attached. The first one is Ambient CG, previously known as CC0textures.com, and the second one is PolyHaven.com. I'm going to briefly show you how to download one set of relevant textures for the workflow in this tutorial, but you are going to have to take the time to find which material textures you are actually interested in for your project. Let's go to Browse Textures here, and then let's search for plaster for the drywall. And then let's see here, this painted plaster wall looks good. And then we can select the image resolution. For this project, I think 2K is more than enough. Perhaps you would choose 4K, but it puts additional strain on your computer when rendering. The larger the resolution of the textures that you use for materials when rendering, the more video memory your graphics card is required to have. So it might be good to start at a lower resolution, and then if you see, evidently, that the resolution is too low for your intended camera view, then you can download the more high-res instead and hope that it works. So 2K for this, and we'll click on the 3 horizontal bars here. And the 3 textures that we are interested in for this tutorial are diffuse, normal, and rough. Diffuse is similar to the captured material's albedo or base color. That is how it looks unlit, sort of, but with some diffuse light baked in. The normal map defines in what direction per pixel the textured surface should reflect light. The rough or the roughness map defines the degree that reflected light should be sharp versus scattered, with a highly reflective versus a rough, dull surface as scalar opposites. EXR is the file format which has the best quality per file size ratio, with 16-bit half-float values losslessly compressed. But if you would like to manipulate the textures in a separate image manipulation software such as GIMP or Photoshop, it might be just easiest to choose any of the other 2 file formats instead. EXR files are not more difficult to implement in a Blender shader than JPEG or PNG, but they are less straightforward to manipulate in Photoshop or GIMP, so we'll stick to JPEG and PNG for this time. For the diffuse and rough, let's pick the 8-bit JPEG, and for the more integer stepping sensitive normal, let's pick the 16-bit PNG. Also, make sure to take note of any stated real-world dimension of the texture. In this case, it was 2 meters. In Blender, let's go to the shading workspace. We can zoom in here with the scroll wheel. Let's see where we can find our metal handle here. Numpad comma, and then in object mode. With the first material slot selected here, as for the glass specifically, we will replace that with another shader later on, but we can use this still as our template. Then let's see here, we can delete the template image by selecting and pressing X. We'll keep the shader node here, as well as the material outputs. In the shading viewport here, let's make sure that we select material, and now it's actually only the glass here that we are changing, but that is of no consequence. Alright, the first thing that we should do is to shift add and add an input texture coordinates. The texture coordinate will be the UV coordinates, that's very good. And then we'll add a value, shift A, and value I don't know where it is. I'll search for value, it's in input value. Click on this node, press N on the keyboard to expand this right hand pane. The label should be UV 0 to 1 space dimension in meters. Then we can expand this a little so that it shows properly. Very good. And this we already know that for all of the unwrapped meshes we have 2 meters as the UV 0 to 1 space dimension. Very good. And then we'll make another value, input value. And this label should be real world dimension of texture set in meters. And this can be set to a default value of 2 as well, if it is 2 meters that the texture takes up in real world space. We should take this value and divide it with this value, and then we should take the UV coordinates and multiply, and since the UV coordinates are a vector of more than one value, we want a vector math, and then we can input this scalar parameter with only one value into the other vector. That's okay. You can zoom out and grab and move this a little to the left. Then we'll add a texture, image texture, and we'll actually shift D to duplicate this so that we have 3 of them, one for each texture in the texture set. The glass material will have no textures in the final material, but we're creating a template for all others, so it's okay. We can open, and then make sure to open the texture that we downloaded, and we can take the metal one, the green metal one, and then it's diffused. So first the diffuse one, we see it here in the right. And since this is a color image of the base color or the diffuse or albedo, it should have color space assigned to sRGB. Now when we open, let's just copy this directory so we can easily move here again. And then we'll take the green metal, and this is the roughness. Grab and move metal up there. This is the roughness scalar values, and they should not have a sRGB color space because this is a non-color texture. These values should be interpreted not as color values, but as linear values. Very good. All right, and then for the third and last one, we'll open, and then we can just paste that direct there, and then we can open this one, the normal one, and then this one also non-color for color space. Very good. And then this vector that we get from multiplying the UV coordinates with the ratio between the UV 0 to 1 space and the real world dimension, that we make sure to have as our input vector. This makes sure that the textures can be scaled with this value node here. All 3 textures can be scaled uniformly. The base color or diffuse or albedo, it should have a U saturation value node here. And this of course is not the U input, but this is the color input. So as to be able to easily change the U saturation value. And this can be complemented with a contrast. And here we make sure that the input is the color input. Very good. This should be our base color. Now this should be reflected in the viewport, or we can change from material to texture. And we see here that we have the base color texture here as our template material. Very good. All right, and as for the continuing work of this template, let's make sure that the roughness value, it should be able to be multiplied, and that is not a vector math, it is simply a math because it's a linear value of a single scale. And then the value here, it should be set as default 1, and then it can be multiplied, and it can be doubled, or it can be halved, and etc. Let's Ctrl Z to undo. All right, this should be input into the roughness input of the shader. Very good. And then as for the normal, it's quite easy. You just click and drag it here, and then you'll do normal map. And this is the color of the normal map. Very good. And it should be set to tangent base. With this node, you can very easily adjust the strength of the normal intensity, so to say. It was 1. All right. Perhaps we should change to the material preview viewport shading here, so that we can properly see this. And it's a little big, but it's okay for the templates. For the actual material, you want to set this correctly. So there we have it, a very simple material, but still with a lot of customizability, especially for the albedo. All right, we can save the file. And as we did previously, when we had the template material, we can actually select everything here. Control C to copy, and then we can traverse between these slots and just do X to delete and Control V to input. And this should be reflected now, exactly. Now the door is also metal, very good. And then we can go to the next one, and X to delete, Control V to to paste, and then next one, X to delete, Control V to enter, next one, drywall, X to delete, Control V to enter, and then hardwood, X to delete, Control V to enter, and then final one, X to delete, and Control V to enter. Very good. And now everything should be metal. We can verify this just by looking around. And even though everything is a little too large in scale, like everything is uniform in scale. So that's good. We'll check from our view here. Yeah, it just looks different, the one above, because it's lit from underneath. Very good. And now let's return to the first slot, or perhaps we can keep the glass slot for the final one. We'll do the second slot here. And then this is the hardwood panel. So we'll make sure to open for these 3 texture nodes, the relevant texture set images. And it was this one. And this is sRGB, very good. And then we'll do the roughness. And this is very important. When you open a new texture, the color space gets its default value. Make sure to change it to the one you want, non-color in this case. And then let's open a normal one here. And let's set this to non-color as well. Very good. All right, and then we should also verify that the real-world dimension of texture set is also correct. Yes, and as a matter of fact, that texture set had 2 meters as its dimension stated as well. So let's move to the next slot. Metal painted, this is what we have here. Very good. It can be kept as it is, except we should of course make sure that the real-world dimension is correct. Let's see here, it was only 1 meter. And this is only reflected on this one then. Tab to enter edit mode, numpad comma. Here we see that when we increase the scale, it gets larger, and when we decrease the scale, it gets smaller. Sorry, now it's negative. 0.01. Now the texture itself is very small, and smaller than it should be, because this is only 1 centimeter, but it should be set to 1 meter, like that. All right, let's proceed to the next slot. That's the floorboards. And then we'll open the appropriate textures that we already have downloaded. And make sure that the color space is set correctly. Non-color for roughness. And non-color for normal as well. Very good. The floorboard texture set was actually 1.7 meter in a stated real-world dimension. Very good. And then you should continue to do this for the rest of these. Okay, and having done so, we want to address the material which should not have any textures, in this case, the window glass. So we can actually delete every node that is to the left of the material output and press X to delete. And then we can add, with Shift A, we can just search for glass. And here we have a glass shader. And we'll connect the shader to the surface here. And we can position them accordingly. And the roughness value can be 0, or perhaps you can experiment a little. And for us, 0.025 was adequate. For the door, it does not look too good. Perhaps it never will, but we'll try to make it look a little nicer. So we'll go to the UV editing workspace. And then let's see here if we... And then I think that if we go back to the shading, and if we change the slot here to the panel, and then we make sure that the last one that we select is the diffuse one, and then we go back to UV editing. That was not correct. Alright, so now in the shading, still in the shading workspace, we just made sure that we first selected the texture as the color in the solid display mode, and then we selected the base color one, and now we can go to UV editing and it should be set as active. Very good. And now we see that it does not look that good. Let's make sure that we are in edit mode, which we were and now we are not. Let's make sure that we are in edit mode, that's correct. And then let's see here that the overlays should be showing. We should select with 3, this face selection mode. We should select this face. And now this is selected here. So now we can select it here. And then we can toggle the overlays here on this button. So now we can manipulate it here in the UV editor, and we still have a clear viewing of it here. All right, so let's see here. If we press period, we can see that the pivot point is a bounding box center, which is good. So it scales from this bounding box of the selected objects. So we press S to scale, and then we'll see here, and this will need to be scaled differently in X and Y. So we scale with S, and then we press first Y and only Y, and we see here where we get, perhaps we should have it like this, and then grab and move it also in the Y direction only, like that perhaps. Is that okay? I think that's okay. And then we can scale it in the X direction, and then let's see here where we get a good or okay result. Perhaps there. Why not? Grab, move it, only move it in X. And then one thing here that I think is good in this case, but might not be for every case, is to toggle overlay again, to select with L this one as well as L that one, and then we grab and move Z to lock it in the Z axis, and then we move it down until it is sort of centered on that texture element, like that. It's okay. And then exit edit mode and enter object mode again. Very good. And then we can go back to the layout workspace, and here everything looks not so normal. So let's see here if we change to material preview. All right, and looking at this, we of course see that the intended materiality is not adequately reflected by the settings that we have chosen. What we see here are just the base textures that we have downloaded. So we want to customize the hue, saturation, value, brightness, and or contrast, so to make them look closer to our intended vision. Let's go to the shading viewport again. And then let's see here. It can be good to be in the material preview display mode here as well. And perhaps also press the numpad 0 to be in the camera. And let's see here. Slot number 1, material glass, we don't need to change anything. Slot number 2, hardwood paneled. Here we might want to change this a little. So I think we should keep the hue. So 0.5 there. The saturation can be a little less. Perhaps 0.65. And the value can be increased to perhaps 1.71 or so. And then brightness, it might be, brightness can be kept at 0. And then we can increase the contrast a little. Like that. All right. And roughness we don't need to change. Okay, moving on to the next one, the metal painted one. Here I think we should zoom in a little with the scroll wheel and going here with shift and the middle mouse button. And here it might be best if the hue was changed to perhaps, something a little more brownish, purplish. And the saturation can be reduced significantly to perhaps 0.49. And the value can be decreased as well, so as to make it darker. Yeah, that looks good. And I don't think we need to, we don't need to change the brightness or contrast. It looks good. And then you just continue to do this for all of these material slots, so that what you see in the camera is actually something that you think is okay. Okay, with all of the materials looking like they should, let's focus on the lighting. Let's go back to PolyHaven and download an HDRI. Let's use this Spruit sunrise as our environment map, which will influence the lighting from the sun and sky, and also influence indirect lighting and reflections. Let's download the 4K EXR. Back in Blender, in the shading workspace, make sure that you select not object shader type, but world. Find the background node here. The background color should be an environment map. So let's Shift A to add a texture, environment texture. Let's open, and let's open the downloaded file. And hook it up there. We don't see anything as of now. If we click this small arrow and do Scene World, then we now see our downloaded HDRI and how it affects the lighting here. To be able to rotate it, we'll do Shift A and do Input, Texture Coordinates, and then we'll do the generated one and do a mapping. Mapping type should be point, and then we put this vector into the input there. We can rotate around the Z-axis. Looks good. The environment texture color space, it can be linear with the 6500 Kelvin white points. It can also be set to non-color, since the values in the EXR are purely linear. Let's go back to the layout workspace. And here we still have the default environment here, so we can change it to scene world and also scene lights, so as to make sure that we include this point light here. And I think that this point light, it's more logical if it would actually be in the center of the small space here. So let's press numpad 7 to be in the top viewport here. And then we can change to solid view mode and hold Alt and press Z, and we can see the objects in an X-ray mode. We can grab and move it, and then in this top orthographic view, we can just position it here, sort of centered. And then we can watch at it, look at it here. Is it reasonable? Can this be a sort of chandelier or something like that? Perhaps we move it a little upwards, like that. And we can change again to the material preview, and we see that, yeah, it reflects very much so up in the ceiling. Let's move it down a little. Perhaps there, it might be hanging like that. If your light source is not showing in your camera view, which it is not, then this might be perfect. If it would be showing, then you of course would want to model something which looks like a lamp and add this point light in a suitable position relative to that. Control Z, we'll keep it as a hidden chandelier. With the HDRI environment map now also lighting the project, I think we can reduce the power of this light to perhaps 20 watts. And then we are ready to do the final render. Go back to the output settings, set the percentage to 100%. If you want, you can also go to render settings and change the noise threshold. For this tutorial, we leave it at 0.05. Let's save the file with Ctrl S and then press F12 to do the final render. After the final result being far too noisy, we changed the noise threshold back from 0.05 to 1/5 of that, 0.01. And then we did it again.
Une heure 14 minutes plus tard.
Alright, so now with the final render finally rendered, we can see that the post-denoising image, the combined pass here, is a little bland compared to the noisy image here. So we're gonna do things easy for us. We can do image and save, and then let's see here. We have here index number 13, cycles, and this was 1 hour 14 minutes. and then a 16-bit RGB PNG, save as image, and this is then the noisy image. So we can do _00 noisy image. That's okay. Save as image. And then we can take the combined pass, the post noise, and then we can save that as well. So let's see here, that one, and then this index 01, and then denoised. RGB color, 16-bit depth. Alright, so let's see here. So first we started with an EEVEE render, real time. And then we switched to the Cycles render engine. And then we used 25% scaling in the resolution, and also with the much higher noise threshold, so as to be able to iteratively work with Cycles render. And then for this first try, for the final image, the denoising pass produced an abhorrent image. So we switched back the noise threshold for the final render to 0.01. This produced after 1 hour and 14 minutes this image before the denoising and this image after the denoising. And as for the render, we see that it is not the best render and it is not the best architecture, but it is definitely something, and hopefully you have learned to do the same. And as a foundation for further knowledge, that just might be of use to you. Thank you for your time.